Hi there. In this series, I'm going to show you how to build a Connect 4 library in TypeScript. In this series, we'll be going over how to create a reusable TypeScript class from scratch that can be used to build out various implementations of the game Connect 4. I'll be showing you how we can take our library and publish it to npm, and then how we can use that npm package to create implementations of our game. As an example, from the library that we build, we could build a game like this using Contra.js, an HTML5 JavaScript library, to build a game Connect 4. We could also use it to build a CLI type game using Node.js. So as an example, using that same library, we can build out our game like so. So in this series, we're going to take a look at the game Connect 4, we're going to review the gameplay and the rules, and then we're going to go ahead and plan out our library, which will have our API contract for anyone using our library. From there, we'll add in our game logic, we'll add tests to validate everything's working properly using the UVU framework, and then finally we're going to go ahead and publish our npm package up to npm, so that way we can then download and install our package in other projects. In order to follow along with this series, you'll need access to the following: a development environment that has Node 16 installed, a code editor of your choice. For this series, I'll be using VS Code. You also need some familiarity with JavaScript. We won't be going over the basics of JavaScript in this series, but you should be able to still follow along. Lastly, we won't be going over the basics of TypeScript. However, you should be able to follow along if you're not familiar with TypeScript. Alright, so before we get started writing any code, the first thing we want to do is set up our project. So for this series, I went ahead and created an initial project skeleton as a starting point for the library we'll be building. This project skeleton has the initial project structure for building a TypeScript npm module and has support for the following. It has test setup using the UVU library, linting with ESLint, as well as the project dependencies necessary to compile our TypeScript code. So in the description of the video, there will be a link to the project skeleton here. If you're at the repository, if you go to tags, there'll be a project skeleton tag, and this will have a zip folder that you can download. If you're familiar with GitHub and Git, you could also go ahead and fork the repo, and you want to copy the branches. There's a branch called project start. This will have the same source code that's inside that tag. So you'll want to go ahead and download this either from the tag, fork in the repo. You can even just go ahead and just download a zip here as well. Once you have the files, go ahead and unzip those. You'll want to go ahead and open those into your IDE of choice. Alright, so once you open up the project in your IDE, you should see the following project structure. And so the first thing we want to do is go ahead and install our project dependencies. So to do that, I'm going to go ahead and run yarn install. If you're using npm as your package manager, you can just do npm install. And what that will do is it's going to go ahead and grab our dev dependencies from our package.json and their versions and install those. So to make sure everything's working properly, we're going to go ahead and test building our project to make sure everything compiles. We can do this by doing yarn build. Or if you're using npm, you can just do npm run build, and that will run our build script that's listed in our package.json. So if everything works, you should see done with some number of seconds it took to compile the project. All right, so we'll go ahead and review our project structure real quick. So in the .vs code folder, this folder just contains configuration files for the VS Code editor, which will allow you to have things like auto-linting and custom launch configurations for running the test. If you're not using VS Code, you can go ahead and remove this folder from your project, or if you don't want that functionality as well, you can also remove it. The config folder, this contains our configuration files for both ESLint and TSC for building and compiling our project. The dist folder will contain our compiled code. So as we're testing our library and building it, it's going to compile our code into this folder here. And once we finish our library, this will be the source code that we'll be using to create implementations of our game. Node modules folder is just a dynamic generated folder that contains our developer dependencies while we're working on a library, as well as the regular dependencies if there is any. Our source folder will contain all the source code for our library. Currently, there's just this root index.ts file that just exports out our class. And our Connect for just has a default class with some comments detailing some of the functionality that we'll want to code for. Next, we have our test folder. So this just has some initial tests that aren't really testing too much using the UVU framework. Just an example, we test that we can create an instance of our Connect for class. And so as we start adding in our game logic, we'll add new tests to test our functionality. That's how we'll test our library. So the git ignore file, this will tell Git to ignore certain files and not to commit them to our repository. So if you go ahead and set up a Git repo for your project, this is how you can ignore certain files to make sure they don't get committed. Typically, these will be things that are dynamically generated, so like our dist folder and our node modules folder. Next, our package.json. So this just is the initial configuration file for npm that has the metadata for our project. So it just has things like the name of our npm package, the version description, our scripts for running custom commands in our project, as well as our dev dependencies we need for compiling our code, and just a few others. Finally, we have our tsconfig file. So this is just the configuration file for TSC that will tell TSC how to compile our code. So this will take our TypeScript code and convert it over to JavaScript. And then finally, the yarn lock file. Since I am using the yarn package manager, this is the equivalent of the package lock JSON file from npm. So this will have the packages and their exact versions. So that way we can have repeatable builds of the project. All right, so before we get into the code, I want to go ahead and take a second to do a quick review of the game of Connect 4, as well as review the business logic so we can go ahead and plan out our game class. So in the game of Connect 4, it's a two-player board game where players will take turns dropping different colored tokens into this 7x6 grid here. So the objective of the game is you want to be the first player to get 4 of your tokens in a row. It can be a horizontal, vertical, or diagonal row here. So like in this animated GIF here, you'll see that the red player gets 4 of their tokens into this diagonal, so they would win the game. So to play your game, you want to go ahead and drop your token into the top of the game board, which will then have your token fall down the vertical column, which will then result in it falling to the next open space. So you see, as we're playing the game, the tokens will basically stack on top of each other, and that's how you want to be strategic in where you're placing your tokens. Finally, if the game board fills up and no one has won the game, it will end in a draw. So just to see an example implementation with the Connect 4 library, you'll see here we'll go ahead and drop tokens into our game board. So we'll have player 1 be red, player 2 will be yellow, and just the objective is we want to go ahead and drop these tokens to try and get 4 in a row. So you'll see here we have 4 in a column, so player 1 would win the game. So now that we've reviewed the game of the Connect 4 and we see how the game actually plays, we're going to go ahead and review and plan out what functionality we're going to need in our Connect 4 class. So the first thing we need to represent is the Connect 4 board. So for our board, we're going to go ahead and use a two-dimensional array that will have the dimensions of 7x6, so to represent that Connect 4 board. And if you're not familiar with a two-dimensional array, this is basically an array that will contain another array. So just for example, so if I just do const r equals an array, and then inside this array, I would just have another array of values. And then to reference these values of this array, I would grab the first index so of the first item. So that's going to be this array here. Then if I want to go ahead and grab the second element of this array, I would just pass in that index, and that's how I'd reference to here. So for our 2D array, we're going to go ahead and initialize all of the inner values, so each of the subarrays with the value 0. And what we're going to do is for our player's game pieces, we'll use the values 1 and 2 to represent each player. So for our array, I'll go ahead and add this back. What we'll do is we'll just do zeros as our initialization. So this just represents an empty space, so no game piece is there. And as a player adds their game piece to the game board, we'll just put in those 1s and 2s. So when we're playing the game in Connect 4, there's really two things we can do. The first is we drop a token, so we make a move on our game board. So we drop that token into a column, or we can start a new game by removing all of our game tokens from the board. So in the game of Connect 4, you can slide the bottom piece to go ahead and remove all of the game pieces. So for our game class, we just have like a reset game, and this will reset the internal state. So to represent these two things, we'll go ahead and add two methods, make move and reset game. All right, and then finally, for our game state, we need to keep track of a few different things, and we want to expose these values as properties on our class. So the first will be our board state. This will be needed so we can render out our current board and where the player's game pieces are currently placed. So that way, as we create implementations of our Connect 4 game, this is how clients that are using our library will be able to show the board state. Next, we'll need to know the current player's turn. That way we can render out which player should take their next move, as well as when we go to place tokens onto our game board, we know which color the token should be. We'll want to know if a player has won the game, and we'll also need an indicator if the game is actually over. So this will be if someone's won or if the game actually ended in a draw. So that way we can inform those clients that the game is done. They shouldn't make any other moves. All right, so now that we reviewed our business logic for our class, what we'll want to do is go ahead and start adding in our private properties and our class constructor to start building out our code. So the first thing we're going to do is let's go ahead and clean up this code down here, and we'll come into our Connect 4 class, and let's go ahead and add an empty constructor. Then what we'll want to do is we're going to start adding our private properties. So first, we'll go ahead and create a property for our board state. So we're just going to do a private property called board, and we'll set it to an empty array. Then what we're going to want to do is create one for our player's turn. So we'll go ahead and do player's turn. So I'm going to set that to a string. And then what we'll want to do is create one for if the game is over and if there is a winner. So we'll do another private property. We'll do is game over. Set that to false. Then we'll do game winner. We're going to set that to a string. All right, so next what we're going to want to do is we're going to go ahead and add a few additional types to support our class here. So we have a few properties that we want to go ahead and be a little more restrictive in the values they can take. As an example, for player's turn, we know that we only have two players in our game, a player 1 and a player 2. So we don't want it to be just a raw string where we take any value. We want to go ahead and restrict this to an enum of values that we know. So to do that, we're going to come above our class and we're going to go ahead and create some additional types. So the first thing we're going to do is we'll make an enum. So we'll do export enum. I'm going to call this player. And for our values, we'll have 1, set that equal to 1. Then we'll have 2. We'll set that equal to 2. And then what we'll want to do is down here for our player's turn, we're going to go ahead and type that. So we're going to type it to player. And then for, instead of setting it to an initial value of a string, we'll go ahead and just do player.1. And then likewise, we're going to want to do this for our board. So for our board right now, we have it as an array that's any. So any value can be put into our array. We know that we only want the value 0, 1, and 2. And we also want to expect an array as the first as one of the values. So it'll be an array of arrays. So to do that, we'll go ahead and create a new type. Do export type cell range. And for this type, we're just going to go ahead and set it to our value 0, 1, and 2. And then down here, for our type on our board, we're going to do cell range, and we're going to have an array of arrays. And then what we'll do is for our game winner, we're going to go ahead and type this to go ahead and be either undefined or a player. And since it's going to be undefined, it can be undefined, we'll go ahead and take away our initial value. And so basically for our game winner, if no one has won the game yet, it'll stay undefined. If the game ends up being over and it's a draw, this would also stay undefined. If someone does win the game, then we'll actually set this to the appropriate value. All right, so now that we have our private properties on our class, we need to expose in a way for our clients to actually get these values. So with these being private right now, they're not exposed to anyone that uses our class. And so what we can do is we can either create methods to expose these values, or another way we can do this is by creating a getter for our fields. And so this getter will allow us to use the get keyword to bind an object property to a function that will be called when that property is referenced, and it can return a copy of the value of these internal values. So to do this, what we'll do is below our constructor, we'll create a few getters. So I'm going to do get board, and board will return our type here, so our cell range. So let's go ahead and type that out. And then for this, we're just going to do return this dot board. And then we'll want to do a getter for each of these properties here. So we're just going to copy this block of code. We'll paste it a few times. Then we'll just need to update the names and the return values. So we'll have players turn. Have is game over. And then game winner. And then we'll just want to copy our types. This will be a Boolean, and then a player. All right, so with our getters, now we have a way for clients to interface with our class and get the values that they need. All right, and so one last thing we're going to do is we're going to update the value that's being returned from our board getter. So by default in JavaScript, your primitive data types, when we have a getter for them, the getter will just return the same value that is set for that property. So as an example, our isGameOver getter is going to return the same value that is assigned to our private isGameOver property, so false here in this case. Versus more complex data types, JavaScript will return an array, will return a reference to that complex type. So as an example for our array here, even though our board getter is referencing our board, so as an example, our board getter is referencing our private board property. And when we return this, we're not actually returning the exact same value of our array, we're returning a reference to it. And what that means is anyone that gets a reference to our array, they can change the internal values, and that's going to affect our internal state. And the reason for that is because since it's a reference to where that data is stored in memory, that reference can modify and change that original data. So the best way to see this is as an example. So what I'm going to do is at the bottom of our class, we're going to go ahead and create an instance of our class. So we'll do const, and I'm just going to call this C. We'll set it equal to connect4. Set it to equal a new connect4. That way we create an instance of our class. And what I'm going to do is I'm going to do a console.log, and I'm going to do our board. So I'll do c.board. And what I'm then going to do is, so that way we actually have a value, I'm going to go ahead and populate this with just some dummy data. So I'm going to do 0, 1, 2. And then down here, I'm going to do c.board. And I'm going to reference our values. So I'm going to do our first element in our array. I'm going to modify the first element of that subarray. I'm going to set it equal to 5. Actually, not 2. That way the types will be happy. And then I'm going to go ahead and console log out our board property again. So what I'm going to do is if you do npx ts-node, what this will do is it'll use the npx command to reference ts-node. So this is an npm package for running TypeScript code directly without having to first you compiling it and then running the JavaScript file. So I'm going to do source, and then I'm going to go ahead and do connect4. And what npx will do is it's going to download this npm package if you don't have it available, and then it's going to run the tsnode command with our file. And so what we'll see in our console here is we have our initial array with the values that we expect, because we initialized our array with the values year 1 and 2. And we then grabbed a reference to our board, so our internal board proper here. And then we went ahead and modified the value. So you'll see, even though this is a getter, we can use it to modify the internal state of our class. And that's not something we want. This to be locked down. And so what we actually need to do is return a copy of our array. And there's a few different ways to do this. One easy way we can do is we can stringify our array, which will return a JSON stringified version of it, and then we can go ahead and parse this, and this is going to end up resulting in a new value. And so we're going to return a new array that is not coupled to our internal. So what I'm going to do is I'm going to do JSON.parse, and then JSON.stringify. We'll do this.board, and then what we need to do is, because JSON stringify is going to turn it into a string, and then when we parse it, TypeScript just returns it as an any. So we actually need to type this as what we're returning. So since we know this is a cell range, we're just going to type this as our cell range array. And then what we'll do is we'll save our code. If we run the same command again to run our code, what we should see is the expectation that we want. We'll see that we grab a reference to our board state. We then modify that new board state value. So because this is a new array, we modify that array, and then our internal board state is not modified, so it still has 0, 1, and 2. That's the functionality that we want for our Git. So just to recap, the reason we're doing this is just because in JavaScript, when you don't have a primitive data type, so like an array, your getter is going to return a reference to this. This is also the same thing as if you have a variable and you assign it to another variable, you're actually assigning it to a reference, not the same value. So something just to keep in mind when you're working with your variables. All right, so now that we have that, we'll just go ahead and clean up our code, and we'll go ahead and save real quick. All right, so the last thing we're going to do is we're going to go ahead and add our 2 initial class methods that we discussed. One for resetting the game state, and one for allowing a player to drop a token into one of our columns. So for that, we're just going to create our 2 public methods. So the first one will be called reset game. And this method is not going to return anything, so we're going to type the return type as void. I'm just going to add a to-do here. And then for our make move, we're going to do public make move. And so this method is going to expect one argument. It's going to have one parameter. It's going to expect the index of the column of where we want to place our game piece. So I'm just going to do col for column. We'll set our type to a number. And then we're also going to do a return type as void. And we'll add a to do. All right, and then the last thing we're going to do is we're just going to go ahead and clean up some of the initial comments in our code here. And just so it's a little bit easier to focus on what's here. All right, and let's go ahead and take our methods. Let's move them below our getters. Generally, we'll want our constructor near the top of our class. And then I like to put my getters above my actual public methods. All right. All right, if you save. So now we have the initial skeleton for our class. All right, with that brings this video to an end. So thank you so much for watching. I hope you really enjoyed the content. And the next part of the series, we're going to take a look at adding in the game logic for setting up the game when it's initialized, adding in the ability to reset the game state, and finally we'll take a look and we can start actually testing some of our code using the UVU test framework.